Hello. I just wanted to talk today about greenplum workload management and CPU usage, memory usage, and do a little demonstration on how all of that works. What I have here is you're seeing a performance monitor running on a 6-core CPU system with 16 gigabytes of RAM, and we're running off of one 2 terabyte disk at this moment. Of course, if we had a RAID array, it would be a little bit better, but it actually shows the issues, I/O issues, more distinctly with this setup. So what I want to do is, I have a table in here, right here, the fact time performance table. Right now it has 5 million rows in it, and what I'm going to do is run a select star from it, do a full table scan on that table, and you'll see how memory gets used up and how CPU is used while doing the scan. I have 6 segments, or I'm sorry, I have five segments and one master actually on here, and they're all running on the same system with greenplum single node edition. So let me run this, just the one select statement, doing a gathering 5 million row result set. So when I press return, it's going to start gathering the information. So what you see is, all of a sudden you'll see over here, you see a lot of CPU spikes jumping up and down. Right down here, if you look, the green line is growing. That's the used memory right now. So the amount of memory being used is slowly growing. It will grow up to, the 5 million rows is just enough to where it pretty much fills up that 16 gig of RAM, not quite though. So the result set actually fits within the 16 gigabytes of RAM. But you'll see the different CPUs running. There's 3 of them that are spiking up and down. Actually not too heavy on CPU, although certain CPU processes are working fairly heavily. Right about here, when it shows that, right now it's gathering up result sets to the master. So all of this previous stuff was from all of the segments gathering information. Now the result set is being gathered from the master, and because there's just one process being used fairly heavily. So when it gathers result sets from the master, it actually, the segments are not very busy, but the master is very busy gathering result sets. Pretty soon we'll actually see the result sets start coming up on the screen above it where we actually entered that command. Very soon, we hope. But again, it's creating a 5 million row result set to actually produce there. So once it produces that result set, as you see up here in this screen, the second it did that, then CPU went down. CPU is not working very much, but memory still is sitting there until you actually accept that result set, and all that result set is put out. It keeps the memory. If you look, memory is still high, even though CPU is now down to almost 0. So when I Control C, it will actually throw away that result set, but which will clear memory. So I'm going to hit Control C right now. If you notice, immediately you have CPU go up, but you have the memory go down to 0. It comes back down. CPU blips up for a little bit just to clean up everything. So what happens if you run out of memory? What we're going to do is rerun this command and wait for it to actually give you the result set, so you're going to see the same basic thing. Although when you run it twice, there is some parts of this structure that's actually kept in memory, so a lot of times it'll actually happen faster when you run it a second time. It really depends on what else is going on in the system at this point. But you can see CPU jumped up, a handful of the CPU right here. The second we entered it, CPU jumped up, back up. Memory is slowly growing as it's building that result set again. And what I will do after it actually creates that result set, if you notice, I started about a minute ago right now. So I'm going to time it far as how long it takes to actually get the result set of 5 million rows with this system. So that's 1 minute right now. We're at almost at 1:15 minute 15 seconds. When it gives us the result set, we'll take that time down as the average time that result set would take. And what you'll find out is once you run out of memory, it starts spilling to disk, and you'll see that actually happen. But once it starts spilling to disk, it will actually at that point slow down your average result time. So there, we just got it. So that was 1 minute 45 seconds about. So while this is running, what we're simulating is if you have two large queries come in at the same time. So in this window, I'm going to do the same thing, yet we're done with the query. If you notice, CPU came back down, but we still have a lot of memory. It's still in memory. It still hasn't accepted the result set yet. So we'll run it in this window. What you're going to see is CPU is going to go up about to where it was before, but the second it tops out right down here, boom, you ran out of memory, CPU starts dropping down. What it's doing now is actually thrashing the disk. It's filling up spill files on your temp directory in your PostgreSQL base directory. So right now it's reading from disk and it's writing to disk. So you have a lot of I/O contention at this point, just going back and forth. And there's so much I/O contention that the CPU has actually become not very busy. You also will find out, we could wait a minute and a half and you'll find out, or a minute and 45 seconds. Right now it's up to 30 seconds. So we will wait a minute 45 seconds and you'll find out it's not even done, not even probably 10% done. So it's right now spilling to disk, slowing things down. You'll even see that the mouse doesn't move very quick, so the system is so busy reading and writing that it's not actually servicing things correctly, including the system log. So we're at a minute 30 right now. We're still not back. So 15 more seconds. What I'm going to do is hit it Control C, and you'll see how long it takes to actually service the cancel on that. Actually, what I will do is Control C this one to get rid of the original set. So it's minute 45. So we're still not back on the other one. It's still trying to create it. So this is showing you that things will get even slower if you have too much, if your workload is too high. And that includes displaying your result set or returning your result set itself. So let me Control C. It'll take a while for it to actually, Control C, CC. It takes a while to actually take effect, that Control C. There, it finally took, right here you can see it did some stuff. It actually had CPU and then dropped the memory down. If you notice, the memory is about it was only about a third of the way up right here. So that means that this one was only a third of the way done, and it was already twice the time. So what I'm trying to show you is if you overrun your memory and start spilling to disk, greenplum becomes very, very inefficient, and it's actually faster to have your workload in a queue that gives you your result set, and after it gives you a result set, it goes on, and after it clears that, it goes to the next one. It's actually faster than trying to run them both at the same time. You run them both at the same time, the system goes into a thrashing state at which it can no longer be efficient. Now we're even though we canceled the middle, it's now another 2 minutes, and it's still not done. So it has to deal with all the thrashing and the spill files and all the cleanup of that. It actually didn't start reprocessing that query till here. So there was a good 2 minutes of waste there. So now it's pegged out. We should get a result set back. So it will handle it. It's just that it's very slow, and the more you thrash the disk, the less efficient it's going to be. So this is what I'm trying to prove to you, is that workload management is very important. Once it gives us this, I'll show you an actual Cartesian product. Cartesian product there, it just gave us our result set. So there, it took about 4 times as long with 2 of them running as if you ran them sequentially, which would be 2 times as long. So let's control that, control C that. We control C, which brings memory back down to 0, and it will take a little bit of CPU to clean up everything. And we're back down to 0 on CPU and memory. So let's go to the Cartesian product. This Cartesian product is very simple. It's just going to run a Cartesian product of that table and itself. So 5 million times 5 million rows. And you have to be careful with this. I'm running this as GPadmin, if you notice. GPadmin is able to run that because it does not go through a queue. Again, that's something you have to be careful with. So if you have somebody running things as GPadmin, or if you have your queue set too high, you can actually bring down your machine. So I'm going to show you that. Oops, there it is. There, now I'm running a Cartesian product, and what it's going to do is run out of memory almost immediately. But one thing to note is CPU comes up and does a lot of work on all the segments, but the second you run out of memory, CPU drops. CPU is not what you're being bound by. You're being bound by the amount of memory. And then once it starts thrashing to disks, doing spill files, not only is it filling up your disk, it's also your I/O is also out the roof. So your I/O goes way up, and your memory goes way up. I mean, your memory usage is at maximum, and it just sits at maximum until it gives you a result set. Last night I ran this, and it actually brought the system down to the point where I couldn't even cancel it. I wasn't able to do anything with the system. It just eventually it takes all of its time servicing the spill file, and you never actually get a result set back. And that's basically what you never want customers, or you never want your users to be able to do this. This is why you need a cost limit. See right there, which I can't really show you because the mouse isn't working. Right there is when it ran out of memory. And you notice CPU, see now my mouse is no longer acting right. The system is fully consumed by writing to disk and reading from disk. And it's going to try to come up with, whatever was it, 10 billion rows, whatever it is. So it will just get worse and worse until you get to the point where you can't actually do anything. So I'm going to control C out of that. And it's actually right now, it takes a very long time to control C. Cancel request sent, but it's not actually done yet. You can actually see that it sent it, but it takes a long time to actually accommodate that cancel request sent. Because it's busy thrashing the disk. It takes a long time to actually clean up. You never want your system to get to this state. That's why, again, why you want to use workload management to control what's going into your system. This query should be stopped by a queue, a maximum cost on your queue. And the queue would just say the cost is too high, dump it out, it wouldn't bring your system down. If you don't have that, or you run something as GPadmin, you will bring your system down to the point where it's of no use. You can't even get in to cancel things. If you notice, it still hasn't canceled. It takes a very long time to actually cancel. We'll wait till it actually cancels. I have been able to get it to cancel, but it does take a long time. So this is a simple demonstration on why you want workload management set up correctly in your system. You need to control what is running in your system. Small queries, no big deal, but the large queries, especially anything that would be anything near a Cartesian product, you want to actually, on average, stop, because it's probably a mistake. Most Cartesian products I've seen on systems come from somebody there, finally actually cancel. But most Cartesian products are mistakes that somebody accidentally happened, or a rendered query came up bad or something like that. So now, if you notice, it just shut memory all the way down. Now you're back to normal. But if I had let it go long enough, it actually wouldn't come back. Last night, I had to actually power off the machine. The mouse wasn't responding. I couldn't type anything. It was totally gone. So, well, thanks for watching. Hope this helps. Thanks.